Well, hello there guys, Mr. G here, and we're going to be making today another question on collision. Now this question is a little bit challenged. It was also a question that was done in one of the exams in the Northern Cape province. It's a little bit challenged, but we're going to see how to approach the question, and then after this it shouldn't be a problem. Okay, now this question says the sketch below show a steel ball A with a mass of 0.46 kilograms attached to a light and extensible string with length 0.69 meters, and it is released when the string is horizontal. At the bottom of the trajectory path, it collides with a steel block B of mass 2.27 kilograms. The collision is elastic. This is the most important part of this question. If you don't notice that the collision is elastic, you won't be able to answer the question. Ignore the effect of friction. The friction is down there. Okay, there is the word friction fixed. And here is the situation. Now we must remember that the velocity of that steel ball A here at this point is going to be 0, and that will be the initial velocity. Let's write it I, still using the and this steel ball is going to move all the way down, and eventually here it's going to hit the block. This collision between ball A and block B is elastic. That is important. Okay, that is very important. Now what happened here, we don't have more data. The only data we have is that the velocity initial of the ball A is 0, the collision is going to be elastic, and the length of the rope that is holding the ball is 0.69 meters. It is important data because that means that is going to be the length here as well, and in other words it's going to be the height, you see. So that is important, 0.69 meters. So it's important data as well, but this is not much given. Now question 1.1 state the law of conservation of mechanical energy in words. So let's state that law real fast here. So this law states that the total mechanical energy remains constant in an isolated system. In an isolated system. Let's fix that word there. So this is what the law states. The total mechanical energy remains constant in an isolated system. Remember before in one of the videos I told you that if they ask you for a law before, it's because you are going to use it immediately after, with a high probability of doing that. So question 1.2 say calculate the speed of the ball when it hits the ground, or when it hits block B, sorry. So when ball A is there, we are going to use the law of conservation of mechanical energy from this position to this position to calculate the velocity of block A just before it hits the block B. That is the question, ball A just before hitting block B. So let's quickly answer that question there. And we've done many questions like this one, so we're going to fast forward. Okay guys, I want to show you something here before I do the calculation. The mass is a common factor in both sizes. So it's the same mass here and it's the same mass there. Now you would say, what will I speak about that one? Because in this type of question actually we don't need the mass. In this question specific, we don't actually need the mass, and sometimes they don't give you the mass and then you will be lost. So note that the mass here is a common factor in both cases. So for instance, we can say, and this is just out that I'm using another color here, we can say that this is 0.46 open bracket half multiplied by 0 square plus 9.8 multiplied by 0.96, and this is equal to, there is also a mass here, same mass, a common factor, 0.46 bracket half the final square plus 9.8 multiplied by 0. And if you notice here, then mass can be simplified. So that is why I explain this one real fast, because sometimes you don't get mass and you don't know what to do anymore. Okay, anyway, now if you see there, this one is multiplied by 0, and this one is multiplied by 0 there. This one is 0, this one is 0 there. Okay, so the final answer for this final velocity would be 3,68. So the final velocity of ball A is going to be equal to 3,68 meters per second, and that is the speed of the object, of the ball A, when it's here. Let's write it there. Speed A there is equal to 3,68 meters per second, and note the speed there will be in that direction there. That is the direction of speed A. Okay, now we carry on and we're going now to the difficult question, or difficult part of the question. Before we go to the question 1.4, which is the difficult one, let's quickly write down the definition of elastic collision, which is question 1.3. So we say that a collision is elastic when both momentum and kinetic energy are constant. Now we are ready to the difficult part of this question. This question is a little bit tricky. However, I'm going to fast forward whatever I can. I'm going to do it not that fast so you can see how to approach the problem, okay? But let me just show you something important. The velocity of the block here initial is going to be 0, as we did write it there. I just want to recall that one because maybe we forget, okay? So that velocity initial of the block is going to be 0. And for this question, we are going to be using this direction as a positive. So this is going to be the positive direction. Remember, I said this is a very important step when you select what direction is going to be positive and negative. Okay, now remember also the collision is elastic, and therefore we can use the conservation of kinetic energy, which we did other questions before, so I'm going to fast forward this part. Okay, so after that we go to this point. Now at this point we having a little problem. We have two unknown. We have the final speed of velocity of ball A and the final speed of velocity of block B. So this here is unknown, as well as that there. So the conservation of kinetic energy help us up to a point. So what we're going to do is we're going to call this equation now equation 1, and we're going to stop there. So now we're going to use the other law that we can actually apply to this specific situation, which is the law of conservation of momentum. I'm also going to fast forward. And here again we have two unknown, and therefore we are going to call this one equation 2. So we have two unknowns there, which is the same as the first equation. So we are going to now work simultaneous with those two equations. That is just using maths. So this one is equation 2. So I'm going to show you how do I work with these equations here. Okay, so after we solve this one, we have now this equation. Now we have like terms. If we look, we have this number and this one here. They are like terms, and we have this one and this one, and we are going to group the like terms, and I'll show you. And now here we are in a quadratic equation. Now this quadratic equation have the form ax squared minus or plus bx plus c equal to 0, in which this number here will be a, this one here will be b with the minus at the front, and this one here will be c. This is simple maths, and it was done before in a quadratic equation, so we're going to apply now the formula of quadratic equation. Now, which one is the correct one? Okay, that may be a little bit tricky. Here is the answer when I use the minus at the front of the square root, and here is the answer when I use the plus. Now, which one is the correct answer? First of all, this speed means that the block continue moving to the right, which we don't know if maybe or so it may be. Now, what is the issue? The speed with which that block arrived to the bottom or hit the block, the ball hit the block, was exactly 3,68. So, as the ball hit the block, it cannot move on with the same speed, which is this one. So this answer is incorrect. The speed must be less. So this is the correct answer by logic thinking, and the minus means that the ball in fact bounces back. So that is the correct answer, and then the final part of this question is substitute this one in the equation of final velocity b. And the answer is going to be 1,24 meters per second. So if you want to give the final answer now, as we used to do in the other videos, we're going to say that this one is in the positive direction or forward. And then for velocity final A, we're going to write here, the answer was 2,439 meters per second backward. And this is the question. So the question is a lot of trick, but it's more math than physics. The physics part in actual fact is only this one when you apply both conservation of momentum and conservation of kinetic energy. That is the physics. The rest of the question is just math, but it's a lot of uncountable small numbers and maths. Okay, so this is the question, guys. I hope it helped. I hope you understand. I'll see you next time. I'll try to do the next video will be the experiment. If I can't do it, it's a little bit tricky. And I'll see you next time. Thank you for watching. Mr. G here.